Good morning students. I welcome you all for this new topic named as complex numbers. So how to introduce complex number in mathematics, okay? You all know about natural numbers, integers, set of whole numbers, set of real numbers. Complex numbers are different from real numbers, children. So how to define complex number is an expression, definition of complex number goes like this. It is an expression of the form, x plus iy, where x and y are real numbers, children. X and y are real numbers, and I is equal to, this I which you see, its value is equal to under root minus 1. Okay students, this expression is called as the complex number. This expression x plus iy is called as the complex number, and we denote it as z. We denote a complex number as z. Z is equal to x plus iy. Okay students, so this is the definition of complex number. A complex number is nothing but it is an expression of the form x plus iy, where these x and y are real numbers, and I is equal to under root minus 1. Such an expression is called as complex number. Okay, and we denote the complex number as z, children. Z is equal to x plus iy is called complex number. Now let us move on to what do you mean by conjugate of the complex number. Conjugate of the complex number. So the conjugate of complex number is defined as, suppose given z is equal to x plus iy is our complex number, children. It is a complex number. Its conjugate, the conjugate of x plus iy is its conjugate of complex number z is defined as z bar, and it is x minus iy, children. Okay students, so x plus iy is the given complex number. X minus iy is called its conjugate. Only you have to change the sign of the imaginary number. In this complex number, children, we say that x is called here, if z is equal to x plus iy, x is called real part of the complex number. Real part of the complex number, children. And y is called imaginary part. Imaginary part of the complex number. Okay students, in a complex number you have two parts here, x plus iy. X is called real part of the complex number and y is called imaginary part of the complex number. So suppose if you want to find the conjugate of a complex number x plus iy, you have to change the sign of the imaginary number sign. So z is the denotation for the complex number is z, children. Z is equal to x plus iy. So its conjugate of z is denoted by z bar. The conjugate of z is denoted by z bar, and it is none other than x minus iy, children. Okay students, this is all about how to define a complex number, how to get a conjugate of the complex number. Okay students, and a complex number is comprised of two parts, the real part and the imaginary part. So let us move on to the properties of complex number now. Let us move on to the properties of complex number. What are the properties of the complex number? Properties of the complex number, children. So there are some properties which you should know before going for the sums. What are the properties of the complex number? Okay, students. So if z is the complex number, x plus iy, and z bar is its conjugate. Z bar is its conjugate. Is its conjugate. Okay, students. Now, how to add any two complex numbers? Look at this, children. Addition of complex number. First property is how to add. So, for addition, z plus z dash I should add. Okay, students. I shall add z plus z dash. So this is one of the property, addition property over complex numbers. So z plus z bar is nothing but x plus iy plus x minus iy, children. Okay, students. So plus iy minus iy cancels. You can add real part with real part, imaginary part with imaginary part. So 1x plus 1x is how much? 2x. So z plus z bar is equal to 2x. So the answer is 2x, children. In this case, you don't see any I part here. So it is called purely real. Purely real, you can say, because we don't see imaginary part in the solution. So the second property is subtraction. Subtraction over complex numbers. So how to subtract? Z minus z bar. Okay? Z minus z bar is equal to x plus iy minus x minus iy, children. So what you do is remove the brackets carefully. X plus iy minus into x is minus x, minus into minus is plus iy, children. Okay, students, in this case what you see is x cancels with minus x, children. X cancels with minus x. 1 iy plus 1 iy is 2 iy. 2 iy. So, in this case what you see is real part is missing. Okay. So, this answer will be known as purely imaginary. Purely imaginary. Okay, students. Here there is no I part for the solution, therefore it can be said that the solution of addition of two complex numbers, in this case of conjugates, we see it is purely real. In case of subtraction of conjugates of complex numbers is purely imaginary. And the third property is how to multiply, multiplication. Multiplication of the two complex numbers. Okay, z into z bar, z into z bar, children. So how to multiply? X plus iy into x minus iy, children. So a plus b into a minus b, all know that it is a square minus b square. So we can apply that. A square is x square minus b square is iy the square. So it is none other than x square minus I square y square, children. Laws of indices I have applied. I square y square. And I square value, remember that I square value is always minus 1. I told you all that the value of I is under root minus 1, children. I value is minus 1. Squaring both sides. Squaring both sides, we get I square is equal to root of -1 the whole square. Square get cancelled with square root. Therefore, the I square value is -1. I square value is always -1. So I can replace I square as -1 children. X square minus of -1 into y square. So it is nothing but x square minus into minus plus y square. Okay students. So what do you find the solution here also? Look here children. It is x square plus y square. So I is missing. Whenever there is no I part, it is called purely real part. So therefore here z into z bar in this case is x square plus y square, and it is purely real part. Purely real because there is no imaginary part in the solution of it. Okay students, this is your third property of complex numbers. Okay, let us move on to the fourth property is division. How to divide the complex numbers. Let us move on to the fourth property. The fourth property is divide. Division on complex numbers. Division of conjugates of two complex numbers. See carefully children. Division z upon z bar is our division. So z upon z bar, z is nothing but x plus iy. Z bar is nothing but x minus iy children. Okay. Now how to divide? Whenever you see that division of complex numbers comes, you have to rationalize the denominator children. You have to rationalize the denominator. So I will say that rationalize the denominator. Okay, because you have to end up it in the form of x plus iy form. So therefore, if I rationalize, it becomes x plus iy upon x minus iy. I have to multiply and divide like surds. In case of surds, what did you do? Rationalizing the denominator, you will take conjugate. Suppose 2 plus root 3 is there, 2 minus root 3 upon 2 minus root 3 we would take. So also here x minus iy is below, its conjugate will be x plus iy children. Only we have to change the sign of the imaginary number to get the conjugate. So the conjugate should be multiplied and divided of the denominator. Okay students, this is called rationalizing the denominator. Now multiply above with above, below with below. X plus iy into x plus iy, or x plus iy into x plus iy is x into x, x square. X into iy is ixy. Iy into x is ixy. Plus into plus plus. I into I square. Y into y, y square. Divided by, see, look at this children below. X minus iy into x plus iy is a square minus b square form you see. Okay students. So later what I do is x square as it is 1xy plus 1ixy is 2 times ixy. And here I said y'all that I square is minus 1 children. Plus into minus 1. Minus 1 into y square upon, again below, x square minus of minus y square it is. Because I square is minus 1 children. So therefore you are left over with x square minus y square is a real part. Imaginary part is 2ixy. 2ixy upon x square minus of minus is plus y square children. Plus y square. Okay students. So the last step what you can do is you can divide each. you can divide it like this. Real part by this x square minus y square upon x square plus y square plus I into 2xy upon x square plus y square. Okay students, in this case what you see is, in case of division, you see that it is in the form of a complex number again, because real part plus I into imaginary part. So it is, division will be always in the form of purely complex. It is again a complex number. Okay, division is purely complex again. So this is all about properties of complex numbers, of conjugates of the complex numbers. Okay students, did you follow, all of you? If z is equal to x plus iy, its conjugate is denoted by z bar, and it is got by changing the sign of the imaginary number. Plus iy becomes minus iy. You have to change only the imaginary sign, not the real number sign. For example, if I say 2 plus 3i is the given complex number z, then its conjugate is 2 minus 3i. Okay students, that is how. Only change the sign of the imaginary number. Suppose your z is minus 1 plus 3i. Conjugate of it is z bar minus 1 minus 3i. You have to change only the imaginary sign. You have to keep the real part as it is for the conjugate. Okay students? So suppose your complex number given is minus 2 minus 4i. What is its conjugate is minus 2 remains as it is because it is real part. Imaginary part minus 4i becomes plus 4i for conjugate. Okay students? This is our properties of complex numbers children. So let us move on for more properties. Let us move on for some more properties children. Some more properties. So some more property is, let properties of complex number. Okay students, so let us say, let z1 be the complex number named as x1 plus iy1. Okay students, and z2 be another complex number named as x2 plus iy2 children. Okay. Now again I repeat the properties based on z1 and z2. Like how did we do for conjugates of complex numbers? Addition, subtraction, multiplication and division. Similar way we have to go for z1 and z2. Suppose z1 is one complex number and z2 is another complex number, then the first property, how to add these two complex numbers, you should know. Okay students, so z1 plus z2. How to add? x1, z1 is x1 plus iy1 plus z2 is x2 plus iy2. x2 plus iy2 children. Okay. Here also we shall add real with real children. x1 plus x2. x1 plus x2 is real part, and imaginary with imaginary. iy1 plus iy2 children. Real with real you add, imaginary with imaginary you should add. So then you get x1 x1 plus x2. I is common for y1 plus y2. This is called first property of addition of any two given, let this be two given complex numbers. Let z1 and z2 be two given complex numbers. Then how to add any two given complex numbers is this, z1 plus z2. Okay students, z1 plus z2 I wrote. I have added real part with real, imaginary part with imaginary always. And you get real part, imaginary I part is common for y1 plus y2. Again it is purely a complex number. You got it in the form of a plus ib. Okay students, that is about addition. Now coming to second property, subtraction. Second property is how to subtract any two given complex numbers. So z1 minus z2 children. Okay, what is z1 children? z1 is x1 plus I y1 minus z2 is x2 minus plus I y2. Okay students, z1 is x1 plus I y1, z2 is x2 plus I y2. Add them by removing the brackets. x1 plus I y1 minus x2 minus into plus minus I y2. Okay? You should be very careful whenever it is minus children, because it changes its sign of the two numbers there. Okay? So what you do is real part and real part you write one side. x1 minus x2 is our real part in this. Imaginary and imaginary is plus iy1 minus iy2 is imaginary part. Okay students? So x1 minus x2 plus I is common from, I take out common, y1 minus y2. This is how again to subtract any two given complex numbers. Okay students, that is second property again. This is again a complex number children, a plus ib. I can say this way. Here also, this whole thing can be written as a plus I into b. Complex. Again it is a complex, again it is a complex. Okay students, it depends upon the numbers which we have. Okay students, how to add, how to subtract, I showed. Okay. So now third property is how to multiply any two complex numbers. Third property, how to multiply any two given complex numbers. Third property, multiplication of complex numbers. So I have to multiply z1 into z2. Okay students, multiply. z1 is x1 plus iy1 into z2 is x2 plus iy2. Okay, see carefully students how to multiply. Multiply with this x1 into x2, x1 x2 plus x1 into iy2. So I is here x1 y2, x1 y2. Now with this plus I into y1 x2 or x2 y1. Okay students, the last part is plus into plus plus. I into I is I square, y1 into y2, y1 y2. As I said already, I square value is minus 1 children. I can replace I square as minus 1. So I get x1 x2 plus I x1 y2 plus I x2 y1. Okay students, I'll replace I square as minus 1. Plus into minus 1 is minus 1 into y1 y2. I square became minus 1, children, all of you. I square value is minus 1, remember this. Okay? So now, here the real parts are first and last. No, has no I in it, therefore it is real part. x1, x2 minus y1, y2. Okay, students? Plus, I is common for x1, y2 plus x2, y1. Okay, students? Again you see that it is a complex number. A plus I into B. Expressing it as a complex number again. That is about multiplication of any two given complex numbers, children. Multiplication of any two complex numbers. Now we have to move on for the next property is how to divide. How to divide. Fourth property is division of complex numbers. Division of complex numbers. So divide two given complex numbers this way. Z1 by Z2. Z1 is what? X1 plus IY1 upon X2 plus IY2. Okay, students. So what did I say? Whenever it is division, rationalize the denominator. Rationalize the denominator. Rationalize the denominator. So if you rationalize the denominator, you will get this way. X1 plus IY1 upon X2 plus IY2. I have to multiply and divide by conjugate of the denominator. So conjugate of denominator will be x2 minus IY2, x2 minus IY2. Okay, students, multiply carefully. x1 into x2, x1 into minus IY2 minus I x1 y2. If I multiply with this plus IY1 into x2. IY1 into x2 plus into minus minus I into I square y1 y2 upon x. These are conjugates. x2 a plus b into a minus b there. So a plus b into a minus b is a square minus b square it is. Okay, students. The next step will be, I shall continue this side. The last step of the fourth property, I shall continue here. x1, x2. Here, minus of minus, or else you write up. Minus ix1, y2 plus ix2, y1 minus of minus plus y1, y2. And below it becomes x2 square minus of minus y2 square. Okay, students? So minus of minus plus it becomes real and real add, children. x1 x2 plus y1 y2 above plus I is common for x2 y1 minus x1 y2 upon below thing becomes x2 square minus of minus plus y2 square, children. Lastly, divide this way. x1 x2 plus y1 y2 upon x2 square plus y2 square plus I into x2 y1 x1 y2 upon x2 square plus y2 square. Again you see it is a complex number. These are the properties of complex numbers, children. Let us continue the next part in the next class. Thoroughly practice whatever we have done, children. Without fail, jot it on your papers, all the properties whichever we have done for today. Thank you, children.